Excellent. Okay, so this is DEV109, and we are going to talk about JSON Web Tokens, otherwise known as JWTs, and why they're important to us in the Domino development world. So we'll say thank you very much again to all of the sponsors for their contribution to making this conference happen. And let's carry on because we've got lots to talk about. So this is me. I'm coming to you from beautiful, rainy right now, Vancouver in Canada. Been doing notes and domino development for a long time. You can come back and read this stuff, but Chris and I know each other through a project, and also Chris has just joined the OpenNTF board. And as of last Friday, I am the chairman of the OpenNTF board for the coming year.
And this is me. I'm Chris Bekas from Melbourne in Australia. I've been a long-time Notes and Domino X Pages developer since release 3, full stack and a mobile app developer as well, and recently joined the OpenNTF board member as a board member.
And it's 7 o'clock in the morning where you are, right?
Indeed, and the sun is coming up.
Okay, so what are we going to talk about? We'll spend the first part of the presentation talking about what JWTs are and how they're used, why they're important, what they look like, what their contents are. And then the latter part of the presentation is going to be how they integrate or how we use them with the new Domino REST API tools that are coming in a future, hopefully soon, future release of Domino. And Chris has got a couple of demos to show as well. So starting off with Authentication 101, the key thing to understand here is the difference between authentication and authorization. And this is pretty easy to understand from a Domino perspective, right? Authentication, username, password, you can log into the server. Authorization, access control list will control whether you can access a specific database. So if we step away from the Domino world, those two concepts are the same here. You will authenticate with some identity provider, and it's going to verify your identity. And then the authorization piece is the information that gets put into the JWT that you then pass in your calls to say, I want to get access to this data. And the server will be able to interpret that and understand whether you should or should not have access. Understanding stateful versus stateless, there are two flavors of doing the same thing, and we'll get into a little bit more of that on the next slide. But stateful means that it's an active session between the client and the server. Stateless means that the server doesn't need to remember who you are because you're passing your credentials in that token every time you make a call to the server. So session-based authentication, this is tried and true, 20 plus years. This is how it works in Domino, right? You go to log into an application on your Domino server, you provide your username and password through the browser, it authenticates you, and the server remembers who you are. So while you have your browser open and are using that application on the Domino server knows who you are because of the ID that is stored in the cookie in the client. It manages that for you. There's, the session ID, the important thing to understand here is that there's no meaningful data or no meaningful information that's stored in that session or in that cookie. So it's safe from a security standpoint. And that's not a big deal, but it's worth just keeping in mind. With token-based authentication, that's what the new kids coming out of school are doing. This is how we do complete blank in my brain right now. Good Lord, how did I forget that? Anyway, see, yes, thank you. The single page applications. I'm thinking of microservices. That's what I'm drawing a blank on. But anyway, it's a stateless situation. So once you authenticate, the server that you authenticate with passes back the token, and then it forgets who you are. And we'll get into a little bit of why that's important in a second here. But the bottom line is that token is stored in the client, and it's the thing that gets passed to the server on each API call. Okay, so this is going to illustrate what I was talking about. So the browser makes a call to the server to log in, right? So we do an authentication call, passing in username and password. The server will authenticate you and return a token back to the browser. So that's the first two lines, the first round trip at the top of that diagram. The bottom round trip is now an authorization call. So now you're saying, I want to do something. I want to get some data off the server. You pass the token verifies the signature the server verifies the signature in the token and sends the response. And that response can be, you're not authorized, but presumably, assuming that you're authorized, you're going to get the data that you're asking for back. I'll get you to imagine in your mind's eye a slight difference in this diagram, that the first call and the second call are to different servers. So this diagram illustrates what might happen in a Domino world, but in a non-Domino world, what's typically happening on the web now is that you authenticate with an identity provider that is completely different from the server that's actually hosting the data for your application. And it works perfectly well, because the certificate or the key or that's used to generate the token is shared between those servers. And we'll get into that in a little bit, but that's the basic concept of what we're trying to do here. So why do we use them? Well, you could almost argue that it's because, right? Because that's how microservices work. If we're trying to put a measurement on it, yes, we get some increase in scalability, some increase in performance. Certainly from a security standpoint, I would argue that it's the same, but we definitely want to make sure that it is secure. Portability is by far one of the biggest advantages, but from a scalability standpoint, imagine an application that's being used by 1 million users. And in a stateful situation, that server is remembering who all of those 1 million users are. So if the server doesn't have to remember who those 1 million users are, there's a slight performance improvement in being able to handle that load. From an overall performance standpoint, the server doesn't have to do any lookups. It does have to interpret the token. So, there's probably an equal trade-off there. But again, it very much checks the security box. And from a portability standpoint, going back to what I said before, you authenticate with one identity provider service, and then you can use that token for 100 different applications, and you don't have to re-log into every single other application that you're wanting to use.
Okay, so let's dive into what JSON Web Tokens are. Essentially, in simple terms, a JSON Web Token is simply a token that contains JSON data that's been issued by the server, just like Graham just alluded to just in the slides earlier. It is an open standard, and in fact, according to the specification, JSON Web Tokens are pronounced JWT. So you may hear us refer to them as JWT or JSON Web Token throughout this presentation. The token contains a JSON payload that also contains information about the user. And what makes JWTs or JSON Web Tokens interesting is that they are signed using a secret or the hash or the hash of the JWT, which is then used to verify that the JSON Web Token was not tampered. And why is that important? Because the JSON Web Token that was issued by the server lives and is stored on the client to ensure then that the token has not been tampered or changed by anyone. The signature is used to verify that the JSON Web Token is authentic. The standard effectively was created for JSON Web Tokens primarily to allow two parties to securely transmit information between each other, and then got adopted effectively for authorization. So what does a JSON Web Token look like? So it's a long string of random characters, and it's divided into different parts, all separated with dots. So if you have a keen eye, you can spot that there are dots in between the parts of the JSON Web Token. And it may look like it's encrypted, however, it is base 64 encoded. Let's take a look at it with the highlighted parts now to make it a bit easier to see the 3 different parts of the JWT, all separated by dots. Let's unpack this a little bit further and sort of peer inside the token and see what it looks like. So on the left-hand side of the screen, we have the encoded JSON Web Token, and the right side of the screen, we have the decoded token, which shows us the different parts that make up the JSON Web Token. The first part is called the header, and simply contains metadata about the JSON Web Token. And that typically is the type, in which case, in our purpose, it's JWT, and also the type of algorithm that was used to sign the token. The second part, the payload, is the effectively the JSON message that we want to send and that we want to include. These are also called claims. So it's effectively the data that we want to include into our token encoded in JSON format. And the third part of the token is the signature. So this is generated by effectively taking the first two parts, the header and the payload, base64 encoding those, adding them together, and then running them through a hashing algorithm to produce the signature, which is then added at the bottom of the token. A little bit more on the payload. Effectively, the payload can contain any kind of data that we wish. However, there are some reserved claims which have been established to standardize some of the naming conventions within JWT. For example, issuer of the service that issued the token, the expiration time, which is always in seconds, the subject, which quite often is the user ID of the person, the audience, the intended audience of who is to consume this token, and also things like issued at, which is a time that the token was generated on the server. We can also include private claims or custom claims in the JWT, and that could be anything from a name or a role. For example, if you're an admin, yes or no. Here's an example of what a typical payload would look like within a JWT. For example, here we've got the subject, which is a user's ID, their name, a role, admin, true or false, and also issued at time and the expiration time in seconds. So typically, the JWT payload should never really include sensitive data because it is base64 encoded rather than encrypted. So anyone that gets hold of the JSON Web Token can decode it, base64 decode it, and see what's in the payload. So it's always a good practice not to include sensitive data in the payload. You never want to put, a credit card number in there or something really sensitive, and try and keep it as compact as possible. Okay, so the signatures. So we talked a little bit about the signatures, which form the third part of the JWT. Now, the purpose of the signature is to allow the server effectively to verify the authenticity of the JWT. And the signature is probably the single most useful feature of the JWT because it allows the server to verify that the token has not been tampered. So the server effectively signs the header and the payload and then generates the signature. And we see two different types of signatures that are used primarily. One symmetric, which uses a secret, and an asymmetric types of signature, which uses a public-private key. So in the header, we did see the algorithm that was used, and typically that's what the server will use to sign the tokens. So what's really going on under the hood with the signatures? So in simple terms, the server will take the header and the payload. So you can see that on the left-hand side of the screen. It will take the header and the payload, use the secret, which is something that only we know that we've established for our secret, run it through an algorithm such as HMAC, and then produce the signature. Then to verify the signature is valid, the server will reverse the process and take the header and the payload, run it through the HMAC algorithm using our secret key, which then produces the signature. And if the signatures are then compared with the signature that was generated versus the signature that was included inside the JSON Web Token payload, and if they match, that's great. The server can let you through. We know that the token has not been tampered. So a similar process goes on with asymmetric types of signatures, but in this scenario, instead of using a secret key, we use a public-private key pair, which makes them a little bit more portable across different servers. So the token, once it's been issued by the server, it really has to be stored somewhere on the client in order for the client to subsequently send that token to the server to request, to make further requests and be authorized. And this happens to be one of the most highly debated topic in the developer community. And the reason for that is that there are several pros and cons with each approach on where to store the JWT. Now, largely depends on your use case about where you want to choose to store the JWT. But typically, you may, if you're talking to an API, for example, you may have the JSON Web Token in local storage and then simply send it across into the authorization header to the server. So local storage is a pretty simple kind of API provided by the browser. It lets you set and get key value pairs within the browser. It is, however, accessible by all JavaScript running for your domain, and that tends to make them vulnerable to cross-site scripting attacks. So it is important to sanitize the user input to mitigate against those attacks. The second place to store a JWT, which is quite common, is to store them in cookies. So in this scenario, the JWT is stored inside a cookie on the browser. That can potentially make them vulnerable to cross-site request forgery attacks. So typically, cookies then are set with attributes such as HTTP only, same site, and secure to ensure that the cookie cannot be accessed by any JavaScript on the client. The third and possibly the most secure way is to not to store them at all, but rather keep them in memory of the client. However, that tends to be more complex to manage and engineer in the front-end application, because now you have to worry about what do you do when users open up the tabs or the closed tabs and reopen. You have to have methods and ways to effectively request a new token from the server, get a new token back in order to provide a seamless user experience. So largely these considerations are taken care of for you if you are using an external identity provider, where they tend to have a framework that allows all for that to happen without you having to worry about a lot of the stuff. But we'll talk a little bit more about external providers and how they can be used a little bit down the track. And finally, this is something, as great as JWTs are, it is important to remember that not to include any sensitive data into the payload, as I alluded to earlier, simply because the payload is not encrypted, but rather base64 encoded. So you don't want to include any sensitive data in there. And ideally, the token should have an expiration time. And that means ideally to have short-lived tokens. Since having a long, an everlasting token might be problematic, imagine a scenario where you have a JSON Web Token that's been issued by the server that never expires. Then if that token is ever compromised, an attacker could then use it to make requests to the server indefinitely. And there'll be no way to effectively stop that. So having an expiration date is important because that effectively invalidates the token. And once it's expired, the server will typically reject it. Also, it's important to consider things like when tokens do expire, how you could handle that into the front end, what mechanics and processes you have in place to ensure, again, a seamless user experience. So if the token expires after an hour and you want the user to continue to be logged in, there needs to be some ways to refresh those tokens and get new ones and so on, and also when tokens need to be revoked. And the last point is that you should always use a good, trusted JSON Web Token library to generate the JWT. And thankfully, there are hundreds of JWT libraries for every possible language and framework that you can think of. And JWT.io actually provides a list of well-maintained libraries that you can use to generate tokens.
And it might be worth clarifying there, that's only relevant if you're needing to generate your own token. If you're using an identity provider, you don't have to worry about that part.
Sure. Yes, indeed.
Okay, so now we get into the Domino REST APIs, formerly Project Keep. And what is that and why, or how do these two concepts meet? So I think everybody's pretty familiar with at least the high level purpose of the new Domino REST APIs, which is a kind of low code approach for pro coders to be able to access Domino data from external applications. Modern, secure, standards compliant, a lot of work has gone into it. In terms of how it runs on the Domino server, Keep runs as, the REST APIs, we'll use the new name, runs as a server task. And there's some separate configuration that you need to do in order to make it work properly. And we'll touch on a couple of those key points here. But basically, you can, once it's set up and running, you can use it to build any kind of apps that you want to. Again, as long as you're following the rules from a security standpoint, the APIs are really comprehensive and give you a lot of flexibility to do what you want to do. So the Domino REST API task consumes that token when a REST API call is made to the server, and that's mandatory. You have to pass the token when you make the call, and you can do an authentication against a built-in endpoint inside the Domino REST API service. But really, you should be using an external identity provider, and Chris can touch on the internal built-on one here.
So the built-in Keep authentication endpoint is really there provided for you for evaluation and testing, really to test and try out Keep. So effectively, what it does, it exchanges your Domino credentials and your username password, and then provides back a JSON Web Token. There's an endpoint that you make a post request to. You send your username and your password in JSON format, and if you're authenticated with Keep and with Domino, then Keep will send back a JWT, which is then signed with a random symmetric key, and by default it will expire in 60 minutes or so, but those settings can be adjusted. HCL have done a great job with making it extendable and highly configurable to allow you to change some of the settings as required. It only works with one Domino server because it issues the JWT effectively for that. And again, according to the documentation, it is really for evaluation and testing only currently, although it is in early access beta 3, and some of these things are subject to change down the track. So what does a JWT that is returned from Keep look like? So here's an example. You'll notice in the bearer token within that area, a familiar now looking JWT, all separated with its 3 parts, along with some claims. The issuer, for example, of who Domino Keep in this case, the subject, which is my name, my full name on Domino, along with some scope data such as mail data to let us know that what kind of authorization access we have into Domino, and as expected, the issue date and the expiration time in seconds. So you'll find documentation on all the endpoints that Keep provides. So there's a Swagger UI type of interface that you can use to, in fact, interact with and learn a lot of the stuff. There's a lot of endpoints provided to create users, for example, to delete users, to authenticate, and you'll find all that in the Swagger UI once Keep is installed.
So when you're getting into a production world or even before production, think about using an external identity provider. So some of them are listed across the bottom here. Of course, if anybody's using Office 365, they're already using an IDP from Microsoft in Active Directory, but you can use Keycloak or Auth0. One of my clients uses Okta. They also use something called Ping Identity. And these are worth learning. As a developer, I've been playing a lot with the Ping Identity API, and it's awesome. It's really, really cool to learn how to be able to take an authenticated user, collect some information from the IDP, and be able to launch separate applications, custom built applications. It's actually really quite fun. It's basically all JSON data. But anyway, in terms of how that interacts with the Domino REST API. So the provider, the IDP, has a public key, and you need to collect that public key when you do your Domino API configuration, because that's what's used to validate the JWT. There are specific payload claims that are required by Keep. We'll look at that in just a second. So there's some information that you have to set up on the external IDP so that it's collected or provided in those claims, so that it can be consumed and interpreted properly by the Domino API. And as it says here, it supports more than one IDP. I mentioned Ping Identity because I've been using it. We didn't put it on the screen here because we didn't verify that it actually works with the Domino, but Okta for sure does. So this is a little piece of JSON that is in a configuration file in, this is in Keep, right? And specifically what's going on here is that we're putting the file on the Domino server, and then we're identifying in the configuration settings where that key file is, so that the Domino API service knows where to go and look and get that when it's validating the token. Obviously, the algorithm that's used to do the encryption, or sorry, the encoding is necessary as well. The sum name can be any name. That's not really terribly important, but the other two pieces of information are. And this is what comes back. So when you log into the external IDP, this is the information that the Domino API service expects to see when you pass that token through. So there it's got sub, which of course is the full canonical name of the notes ID. This is not something that the external IDP normally will know. You have to add it. So basically you have to add it as a custom field and then go through whatever the configuration settings are for the IDP to say, include this in the payload that comes back when I authenticate. And then, of course, the other information, similarly, you have to do your setup on the IDP in order to make it look like this when it comes into the token.
Right. Now, of course, there is an option for you to create your own identity provider. Should an external provider doesn't meet your needs and you need to have more flexibility, you can always create your own identity provider. There are some prerequisites. You're going to need, of course, a public-private key pair in order to use that algorithm and let Keep effectively validate the token. So, and you need, again, a good library to be able to generate and sign the JWT. And you need the payload of the JSON Web Token to be as per the requirements that Graham was showing earlier. For example, the audience needs to be set to Domino, scopes, and so on. So you've got a couple of options here. You can roll your own Node.js server, for example, that you then, your front end then does the authentication with that server, and that server will then generate the JWT, which can then be used to authorize requests with Keep. On the Keep documentation, there's some sample code available, some templates to get you started, should you want to go down that path. And you could even go X-agent type of architecture or an X-pages REST endpoint. If you wanted to, for example, retain that authentication upfront with Domino first, and let Domino or your X-agent, X-pages generate the token for you, you could effectively do that. That's one of the options. So effectively anything that can return back a valid JSON Web Token that's been signed with a public key that keep is configured and accepts, then you're good to go. Again, you would only go down this path if none of the external provider options didn't meet your needs and you decided to roll your own service.
Playtime.
Okay.
Let's see it.
So we're right on demo time. So for the developers in the room, that might be a little bit more interesting that we're going to show you some code. So what I do have here on my screen, hopefully you can see that.
Yep. Yep. Yeah, no, it's good.
Is I have a React-based application, which is effectively just simply to illustrate how you can authenticate against keep and get back a JSON Web Token. So it's written in React, but it could be anything. It could be in Vue, it could be in Angular, anything really that can talk to the keep API and return back the JSON Web Token. So if I log in and sign in, so what we'll see that has come back now from keep is the JSON Web Token. So that means I've authenticated correctly. Keep has authenticated me against the Domino directory, and this is me, and I have my bearer token. If we take a peek into the local storage, you'll see that I have the token that's been returned back from keep, and it's been stored and saved within my local storage. If I sign out of this service, you'll notice that the JSON Web Token now is gone. It's been deleted. And again, if I log in, I've been issued with a new token. So this is a fairly simple application that, in fact, is available up on GitHub on one of my repos. So you can take a look if you like, if you want to use it as a starting point or to test things out with Keep. It's a fairly simple application. All that's really happening is I have a component, a sign-in component with my username and password form. And when this form is then submitted, it sends a request to Keep, which happens to be an endpoint, the authentication endpoint from Keep. And I have a local server, a local Domino server running Keep as a task on my local server. That is submitted to Keep. And if it's authenticated and that's correct, it simply returns the token and saves it into local storage. Pretty simple stuff. And like I said, this could be any kind of single page application scenario. It doesn't have to be in React. Okay, the other thing that we thought we might do is to take a look and do a little bit of a debugging on that JSON Web Token that came back from Keep. So if I grab my token and then head over to JWT.io, which is that, in fact, this is provided by Auth0, and it's a really cool way to look at a JSON Web Token, unpack it, and see what's in it. So what we'll do is we'll just paste our token here that we got from Keep. And on the right-hand side, we're starting to see some familiar areas. For example, the header. So the type is JWT. The algorithm that used to sign the token is the HS256 HMAC algorithm. In the payload, we see that the issuer is Domino Keep. The subject is my name, the scopes, and then the issue at the expiry and the audience. So that effectively gives us a good idea of what's inside that JSON Web Token. And you can use this at any time.
Sorry, I was just going to ask, why does it say invalid signature down at the bottom there?
That's a good point. Thank you, Graham. So this will actually attempt to validate the signature, but it cannot validate the signature because the token was signed by Keep with a random secret, which we don't have. So that is a key and a secret that Keep has used to generate the token. and the signature will only be valid if you know what the secret is. So if you're generating your own token, then in this example, a brand new token that we generated by Auth0 by JWT.io, you can put in your own secret in here and experiment and see how this works. If you were to change anything into the token in here, then effectively the signature will no longer match. So it's a good way to kind of, as you're working with JSON Web Tokens, to use it as a debugging service and see what really goes on under the hood.
Okay, so we've added some links here for you to play around with. There's obviously the documentation for the Domino APIs, that link to that website that Chris was just looking at. You know what else we had was there was a really good YouTube video that I've stumbled across that had some good basic explanation of what's going on. We'll add that in here as well. But additional libraries and other articles and information about how all of this stuff can be used is included here. And with that, we're at the end of our slides.
Yeah, and lastly, I was going to say that there is a wealth of information out there on JSON Web Tokens. Luckily, it is widely adopted with full stack developers that are building single page applications. This is how they do it. So there's a lot of information out there of how to do it, and a lot of great videos, like Graham said. So luckily, there's everything is at your disposal.
I think the other thing to say too is that we probably could have filled 2 or 3 hours worth of time with the nitty-gritty details. So this is enough to get you interested and push you off in the right direction. But if anybody has any questions, please type them up in the chat, and we'll discuss. By the way, Chris's GitHub there, that's where you posted the sample code? Or you
yes, yes, exactly, yes, on that GitHub, yes, you'll find that.
Don't see any questions. We'll stick around, but anybody who likes to move on and maybe refresh your drink before the last session of the day, thanks very much for attending, everyone. Enjoy the rest of the conference.
Indeed. Thank you very much. And thank you to sponsors again once more for making this possible.
Any experience with Keycloak yet? Chris, have you played around with Keycloak?
So I've read through the documentation about how to do it. So there's a good guide up on the HCL Keep documentation of how to do it. I haven't actually done it yet, but it's a number of steps you need to do to set it up. But and I think it's available as a Docker image as well. So you could download the Docker image of Keycloak, and that will probably make it easier to get started with.
Another question, Sonar is asking, what about OAuth? Is there any place of it in this picture?
Yeah, so OAuth effectively uses tokens. It doesn't specifically say to use JSON Web Tokens. However, JSON Web Tokens are a good fit for OAuth because as you go through the OAuth sort of dance to do the authentication, ultimately there are tokens involved that are getting sent back, an access token, an ID token, and so on. So JSON Web Tokens have a really good fit for OAuth, and in fact for OpenID Connect as well. So they play a fairly big part.
Yeah, it's more about who the IDP is, right? OAuth is the process, but the identity provider, like there isn't an OAuth identity provider, right? Or is there?
Some of them do. So some of the providers will effectively use OAuth as the mechanism to sort of get you authenticated, and then ultimately at the end of that OAuth process will issue the JSON Web Token that you can then use to pass on to Keep to do your further requests. Yeah, so some of them do go down that path. I'm pretty sure Auth0 kind of does it in that way.
And Bob is asking a question. I assume SSL is a prerequisite to protect the data being transmitted between the client and server.
Yes, I think
Pretty much an
that's
abso-freaking-lutely.
very much absolutely, yeah.
Yeah.
And they keep documentation has again some good guides on how to set up SSL in front of it. Like there's some guides there how to have a reverse proxy and so on in front of keep and or an Nginx to kind of give you that SSL protection.
Wonderful. Okay, that's everything that we've got. So we'll let you all go. Thanks, everyone.
Thank you.